Dear users, now let's discuss the McCall's quality model. McCall's quality model presents this architecture. It says this is the front end of the software, qualities of the front end, and these are the qualities of the back end, or the coding, or the internal architecture of the software. So this model says a software will be a good software if it has these qualities of the front end and these qualities of back end. Definitely the qualities of the front end depends upon the qualities of the back end. For example, correctness depends upon traceability, completeness, consistency. Similarly, reliability depends upon consistency, accuracy, and error tolerance. Now these are too many terms, so I'm not going to discuss all of these terms. So let's discuss these front end terms, and these back end terms are your assignment. So you should go to the Google to search out their meanings and examples and explanations. So let's discuss these front end terms. So first of all, correctness. So what is correctness? Correctness is what customer specifies. If customer says 2 plus 2 is equal to 5, then this is the correctness. You should implement your software to provide the customer 2 plus 2 that equals 5. So correctness is nothing but the customer's specifications. It's not about a universally correct or correctness or incorrectness. Next is reliability. So what is reliability? In everyday life, we say that life is not reliable. What makes life non-reliable? It is time. For instance, now you are sitting here, and your age is you may say you are 20 years old. If you add 200 years to your age, you will be no more. So time makes the life non-reliable. So reliability for software is that software should behave exactly same at time 1 and at time 2. For instance, if whatever the results software gives us at time 1, it should give the same results at time 2. So, and next is efficiency. Efficiency means the maximum output with the minimum possible input. In terms of software, what is the input? In terms of software, CPU cycles and memory are the input. So a software is called an efficient software if it consumes minimum possible memory and minimum possible CPU cycles to produce the results in minimum possible response time. And next is integrity. Integrity of a software is that no foreign body should be able to intrude into the internal private data of the software. Intrusion of external body should not be possible. Like some hackers or SQL injections should not be able to steal our secure data. Next is usability. Usability is simply the software should be easy to use. And I say the best software is that software which is usable without the help of user manual. If the user is using user manual, it means the software doesn't have good usability. And maintainability means the software should be easy to maintain, and it will be definitely easy to maintain if it is very simple and it's not complex. So the complexity of a software can be determined by the cyclometer complexity, and cyclometer complexity is actually the number of decision points in the coding. So if the coding has 3 to 7 decision points, it is easy to maintain, and if the complexity of the coding exceeds 10, then it's definitely hard to maintain. And next is testability. Testability means the software should be easy to test. And For instance, sometimes it happens that some parts of the software are not testable, and those parts which are not testable definitely will not be usable. So the every part of the software should be testable and easily testable. For instance, if someone says that this part of the software can be tested on 30th of February, it means that we will not be ever able to test that part, because we will never get 30th date of February. So for instance, sometimes the softwares who deal with medical life or some other hardwares, and we cannot have that real-time scenario, so those softwares are not easily tested. So for such scenarios there should be some workaround to provide some simulation to test those parts. And next is flexibility. Flexibility means the software should be modular. It should be divided into different modules, and each module should be independent and decoupled, so that we can rearrange the modules easily to customize the software. And the portability is actually the platform and hardware independence. A software should be able to run on desktop machine, on mobile, on laptop, in web browser. So a software should be portable. So the portability of a software makes it a good software if it is able to run on all the platforms. And next is reusability. Reusability means the different parts of the software should be reusable in other softwares. For instance, if you have developed a website, and for that website you have developed a login module, that login module should be reusable in other websites as well. And finally, interoperability. Interoperability means the software should communicate with other applications or with other softwares quite easily. So we should provide an interface to the software so that it can easily communicate with any other applications. For instance, this A application has high interoperability if it can communicate with all these applications. So that's it.